In this video, I want to talk about continued fractions or introduce the topic of continued fractions. It turns out they're going to be really important in number theory throughout the semester, but in particular, we're going to use them to solve linear Diophantine equations much more quickly. So let me just introduce this with an example to show you the process. In some sense, it's an algorithm. So let's just start with something like 65 over 23. That's a rational number. It's in lowest terms. The denominator is prime and the numerator is not a multiple of 23. So it's in lowest terms, but it's one of these mixed fractions, right? It's actually between 2 and 3, right? So it's actually 2 plus, I think you'll find 19/23 if you find the remainder, the fractional part. So yeah, this is called the integer part. And this is the fractional part, which is less than 1, right? So in order to get this to have this sort of be recursive or algorithmic, I'm going to do something kind of goofy. I'm going to take this 2 and then I'm going to take the fractional part and actually flip it over. And now we have a number bigger than 1 again down here, right? This is bigger than 1. This was bigger than 1. Now this is actually between 2 and 3. This 26/5/23. So we stripped off the integer part with the fractional part. Then I'm taking the reciprocal of the fractional part to get a new fraction that's greater than 1. So repeat. I guess that's kind of what I want to say now. Repeat what we just did to this. So this 65 over 23 equals 2 plus 1 over 23/19, but 23/19 is between 1 and 2. So it's 1 plus 4/19, right? And then same thing, we have an integer part and a fractional part down here. And so I can take the 4/19 and flip it over again. So that's 2 plus 1 over 1 plus 1 over 19/4. And then repeat again, repeat. Strip off the integer part, find the fractional part. And you can sort of see that this is going to go on for a while. Is it going to go on forever? Let's stop. So 19/4 is between 4 and 5. It's 4 plus 3/4. Right? And keep going. This is 1 over 4/3 down there. And I think we're going to actually come to a stop on the next step because our 4/3 is 1 plus 1/3. And now this number down, well, really, this is already a reciprocal. It's a reciprocal of 3. So this number is 3. So taking the reciprocal of 1/3 is really writing, 1 over, rewriting, like we wrote 3/4 as 1 over 4/3. If we try to do the same thing, 1/3 would just be 1/3. So we stop. So since this is a whole number, so we stop. Okay, and so in fact, right, so this right here is the continued fraction of 65/23. It's 2 plus 1 over 1 plus 1 over 4 plus 1 over 1 plus 1 over 3. But you have to think of those being nested, these sort of nested fractions, right? So that's called a continued fraction. A notation for it that people tend to write is, we'll write something like this. We'll write 2. Basically, we're going to write the list of numbers kind of along this diagonal. This 2, 1, 4, 1, 3. Some people put a semicolon there. And then just put it in square brackets. So this is a notation for, just because if you're going to talk about continued fractions a bunch, it gets tedious to draw this thing. So we just use this as a shorthand. Okay. So that's a notation for a continued fraction. Okay. And then the last thing I just want to say, just as in this quick introductory video, is, you know, we did this whole nesting under nesting under nesting, and it gets kind of ugly, especially think of this like 10 layers deep or something. It would be kind of unpleasant. But if we write, if you think about where these integer parts, because we really just want to know what these integer parts were, right? We wanted to know what this 2 was, and then this 1, and then this 4. What do they came from? 2 came from the integer part of 65 over 23. What's really the quotient when we take 65 divided by 23? We get a quotient of 2 and a remainder of 19. 23 over 19, when we divide 23 by 19, we get a quotient of 1 and a remainder of 4. So notice if I write, I'm just going to write two things side by side. We actually did the Euclidean algorithm for this. So I'm just going to write this side by side. This was, I'm just going to this was in an earlier video, we did this. So I'm just going to copy it. From before. Uh, 3 times 1 plus 1. And 3 is 1 times 3 plus 0. Right? Where these numbers are the quotients. I think I did that right. So these are the quotients. But notice those are exactly the numbers in, I mean, you can see it. It's exact. These numbers are exactly these numbers. So a quick way to find the continued fraction is just to do the Euclidean algorithm for the pair of numbers and then write out the quotients, and that's what ends up being here, that list of numbers there. And you can see why, because it's the same computation really. Like, you know, just think about converting this into 6, just divide both sides by 23. So it's 2 plus 19 over 23. And for this one, think about dividing both sides by 19. 23 over 19 is 1 plus 4 over 19, right? And you can do that for all of these. So you can really see where these come from. It's really the exact same data information or information as the Euclidean algorithm. I mean, how did I know that like 19 forces between 4 and 5? It's because I divide by 4 and realize I get 4 point something, but that's the whole quotient and remainder idea. So, okay, so divide both sides of this by 3 and you get 1 plus a third and so on. Yeah, I mean, this one you would just divide. You could say 3 over 1 is 3. And those are exactly the things that go into the computations we did up here, right? Okay, so that's the idea of a continued fraction. That's its connection to the Euclidean algorithm. Continued fraction of a rational number. You could do the same thing for an irrational. We could have taken the square root of 2, said that's between 1 and 2, stripped off the integer fractional part, taking the fractional part, taking the reciprocal, and you could do that. And actually those go on forever and there's interesting patterns, but I'm just introducing the continued fraction in this video, and then I'll move on to some other important stuff in the next video. I'll stop there.